So good afternoon to all. Let's begin. I
Good
hope
afternoon.
others are already joined or maybe they are going to join very soon. So let's begin. In the last class, we have discussed the estimation of sample size under SRSWR. Okay, under SRSWR. Now let us discuss same thing under SRSWOR. Exact the same procedure you have to follow here. Exact the same procedure you have to follow here. If you think here, if you just able to see, this is the sample size, you have to obtain the sample size under WOR. Okay. So again, the condition for, under WOR is same. Expected value small y bar is equal to capital Y bar, and variance of Y bar is equal to capital N minus small n upon capital N into small n into capital S square. So this formula we are already knowing very well. Okay. Now here, if you just see the I have not written the procedures. I have written similarly. You have to follow the same procedure, and we'll get directly D is equal to this quantity. Okay, so I'll just uh, show you how we'll get directly this quantity. So if you just see this last derivation, here we have T time sigma upon root n, right? This we compare with D. But what is the sigma upon root n? Sigma upon root n is your actually variance, right? Sigma upon root n is your variance. So similarly here also, you can follow same procedure, write it down similarly as it is whatever the procedure is given for the in the case of WR. Write it down till here. Everything is going to be same, and directly you will be get here D is equal to T times sigma upon root n. Similarly, this is the standard deviation, right? So if I write the standard deviation, I will get square root of this quantity into S. So one can get this directly using the previous derivation. So this is I have written directly. One can go with uh, deriving the previous derivations as in usual case, and they can work out. They can very simple to get this one. So there will be no doubt at all. If you just work on few steps, you will get this one. Square both the sides. If you square both the sides, become d square t square. This quantity becoming without square root into s square. Now take these. Now since here also in numerator and denominator both we have n, so I have to separate n, right? Take this n will be this side and d square will be in the denominator. So it's become n time t square s square upon n time d square. In bracket we have capital N minus small n. So again you can little bit simplify. You can what I did here, t square s square d square. So you can see this is all whole square. So I've just taken, just take this will be the this quantity will be this side and n will be this side. Okay, and then there should be the multiplication of n. There should be the multiplication of n. So there is small correction. You just multiply this quantity by n. I forget to write this n here. Okay, so just multiply by n here. N into this quantity, okay, because this n is there. Okay, so what I did here, I trying to separate the quantity n because n is here, right? So I'll try to make a separate n. So you take this will be or if you just take n will be here and divide by this quantity, and this quantity will be goes there, and just little bit adjustment. So if you just reverse it, it's become d ts ka whole square into divide. This n will be multiplied with d. Okay. And now this quantity n, capital N, small n upon small n, we just get simplified. So this is n upon capital N upon small n minus 1. Okay, so you can just simplify this one. Take this minus 1 will be this side, so which is equating with capital N upon small n. Further we have to take this n, right? Do the reciprocal. If I do the reciprocal, n become in numerator. So n become in numerator, and capital N become in denominator. So again, this capital N you multiply with this quantity, okay. And it turns out to be this expression. Further, you can little bit simplify if you want. This n will be divided. So this n will we just divide this quantity. What I did here, if you trying to understand, this quantity divided by this quantity will turns out to be what? 1 upon, it is d upon ts whole square plus 1 upon capital N, right? And this we have written in different way, means just this term will be here and this term will be here. So divided throughout by n. So 1 upon n, it is 1, and it is 1, it is n. So it is 1 upon n, the whole square, and it is, since it is 1 upon something, I have taken its inverse. So we can just take this. I think this is the, yeah. So this is the basically result we will get in the case of SRSWR. Okay. So you can just have this expression. The expressions we'll get in the case of SRSWR. Now, if capital N is large, okay, so I'm just putting some condition on capital N. If this capital N is large, okay, so if you see the expression, the result of SRSWR and SRSWOR are, this is not sample, this is same, this is same. So if capital N is large, so if capital N is large, you can see this quantity goes away. This quantity will be, capital N is large, then this quantity becomes 0, and hence it turns out to be this quantity, and this is same as your SRSWR. Okay. SRSWR. So this is same as your SRSWR. And similarly, if S square is unknown, same condition. If S square is unknown, then we can take it by unbiased estimate. So you can just see that if it is unknown, then this quantity will be replaced by small s square. And again, if capital N is large, then you can always go by small s. That is very small, like minor corrections. You can always make those correction in here while writing the notes. Okay. I hope it is clear to all. So just go through if you have any difficulty here, because this is exact same derivation you have to follow in WR. Now same derivation you have to do it for attributes. So that was under WR, WOR. Now same derivation have to do it under attributes. So again I have to consider two cases. WR, we know these two quantity. Just now we have seen in the last class. Expected value of small p is equal to capital P. Variance of small p is equal to PQ upon N. So again this small p follows normal with the mean and variance. This you can just substitute these values. These values are there. You can substitute here. Again I'm using standard normal variate, which is z is equal to small p minus capital P square root of PQ upon N, which is again follows normal. So similarly using same procedure, one can directly get these two equations. I hope this is clear because I have just not written few steps. So you're supposed to write few steps using the expression 1. And if you compare this, your d is equal to t times square root of PQ upon N. And then you can just find d square and get simplified and get the value of N from here. And if p is unknown, if capital P is unknown, you have to use their estimates, which is small, and then will turns out to be this result. Similarly, when we have under WOR, then you can have mean, you can have variance. Apply the same technique, same formula. That is your mean minus, that is small p minus capital P upon standard deviation. So you can just substitute. Similarly, applying all the steps, d is equal to t time standard error or standard deviation. So you can get this. Get simplify, square both the sides, simplify. Because why I'm squaring? Because here we have in square root may n. So we need to take n. So we have to square both the sides. Squaring both the sides, adjusting some term here and there, like previous derivations. Okay. So d square is equal to t square into the, and you can see here also we have n, here also we have similar to the previous derivations. You have to make adjustment, right? So in just here what I did, I just get simplify this here only. So this is get cancelled. This remaining is n minus n, and remaining whole thing with this multiplied with this and multiply with this. Okay, and here in second term we don't have any n, so whole thing will be taken this side. So d square into that quantity, t square pq upon capital N minus 1 taken will be the left hand side, and remaining will be t square t pq upon n capital N into small n will be here. So I think this will be the simple here, because as compared to the previous derivations where we are talking about SRSWOR, it is quite gumafira, but you can follow both the derivations. You'll get easily, can get it and detect it. So just work on this and you can get simplify. You will be get the solution very simple. Take then again divide, take reciprocal, again take reciprocal everything. If you take reciprocal, then this quantity goes down, this is comes up. So t square pq upon capital N minus 1. So again you multiply by this n will be here. Okay. So n into t square pq upon n minus 1, whole thing divided by d, again cross multiply. This you can cross multiply. If you just do the cross multiplication here, it will become d square n minus 1 plus t square pq upon capital N minus. Okay. So this capital M minus 1 capital N get cancelled. So remaining here n time, or even I have divided by n here. So if you just divide by n, this n goes away, and this n upon n is 1 minus n plus t square pq upon n. So that terms will automatically come. So again, if you see this capital N is large, then 1 upon n tends to 0. If capital N is large, then 1 upon infinity is going to be 0. Then this is turns out to be your SRSWOR derivation. Okay. Which is so this derivation is similar to your what I have written here. Then this n, this n, this n tending to SRSWR. Okay. Now in star dividing by d square. So this is another form. Okay, this is the one form. This is the one form where I have shown that if capital N is large, then this result is tending to SRSWR. So if you see the SRSWR ka derivation, what will be your N? See, T square PQ upon D square. This is in the case of SRSWR. Is that same? In the case of SRSWOR, when capital N is large, say T square PQ upon D square. So this is exactly same as SRSWOR, SRSWR when capital N is large. This is the one way of doing derivations. But what I did, suppose I am dividing throughout this quantity by D square. What happened? Okay. So I am dividing by D square here and dividing by D square here. So this quantity divided by D square will get, okay, this quantity. And dividing by D square, if you just divide by D square here, this is going to be 1, remaining is 1 minus 1 upon n, t square pq upon d square into n. So you can see this, right? Now let assume this quantity, see, if you see this quantity t square pq upon d square and t square pq upon d square into n, assume those quantity will be small n. So my first approximation of n is going to be n1, which is n naught upon capital N plus 1 minus 1 upon capital. Okay. This is, I'm just trying to making the approximation. See, if we have this n naught, one can get directly n1. Similarly, if we have n1, one can get n. If we have n, I think this approximation of n. Okay. This. Okay, second approximation of n. This is third approximation of n. So based on the approximation, one can go with the derivation. So here, further you can get simplify also. You can just make some adjustment here. N upon n and 1 minus 1 upon n. You can club these two together because their denominator is same. So 1 plus n naught minus 1 upon n. Then if you want second approximation, so this is your n1. For second approximation, write it down same thing. It is n1, 1 plus 1 upon capital N, n1 minus. This is second approximation. And you can get similarly third approximation and so on. So this is, I think, related to approximation. One can approximate the value of n naught also, n also. Okay. So, any question is there? Let me see the chat box. If you have any questions, you can ask. SRSWOR. अच्छा. Yes, बोलिए. Yes. See, the procedure for SRSWR and SRSWOR is exactly same. The only thing is that I am just changing the variance quantity here. The variance quantity change, the whole derivation is exactly same. Whole derivation, nothing is changed. Even the procedure is again same. So if you just knowing this derivation properly, because here only I have written everything properly. In the case of WR only I have written all the steps one by one, because in other all derivations like in WOR I have written directly. Okay, so for understanding this we have to understand this is in thorough. Okay, so you need to understand this quantities, and this is very simple. As a confidence interval we have already seen how it works. So understand this variance part. Variance is sigma square by n. So d, how to calculate this d? This d is actually, if you see this, d is equal to t into standard error, t into standard deviation, not error, t into standard deviation. So you have variance quantity. You have here variance quantity sigma square by n. You take standard deviation. If you leave these expressions, if you are not writing this expression, but in exam you're supposed to write. But for cross checking, you can directly use, if you want directly error. Now in practical, if they will ask you find out the error, tolerance error, then you are not supposed to write the entire derivation. You know the trick. Okay, so to know the trick, we have to just use it, t into standard deviation. Now you just simplify this one and get this directly value. Similarly, you have to do it for SRSWR, WOR, t into standard deviation. So t into standard deviation. Get simplify. You'll get the value of n from here. Similarly, if capital N is large, it is tending to your SRSWR. And similar procedure have to do it for in the case of attributes. So in attributes also, we can assume directly d into pq upon n, because your standard deviation is pq upon n. Variances. Take a square root, you'll get standard deviation. And you can compare it and you'll get the value of n. It is similar procedure. The only thing is that you have to work out little bit. And similarly, you can work on SRSWOR. And again, capital N is large, then it is tending to SRSWR result. This is another way of doing the expression. So I've divided by d square, and I'm trying to get some approximation of n. Some approximation of n. So once you have n naught, one can find n1. This is second approximation. So sometimes they will tell you find out up to third approximation. Okay, find out up to third approximation. So you have to do continue till third approximation. There sometimes they will find fifth observation, fifth approximation. So you have to go up to fifth approximation. So I think with this, unit 1 is over. So if you have any questions, you can discuss. So the next time, I'm very soon I'm going to upload practicals on GC, so you can just go through how this practical works. At least you can write it down, okay, and then we will see. Okay, anyways, you got any instruction related to practical? Any instructions on the practicals? And
No,
how?
sir.
Huh?
No.
Okay. But I think next week on it, we have to start the practicals, because until we will not start the practical, the theory is just goes like, because we will not understand, because it contain all derivation and everything. Okay. But better you can start write it down. Okay. So once you start write it down, you will be know very well, because okay. and make sure that all formulas and everything you should know. So starting from the if you're starting from the very top, starting from the derivations like this, basic definitions like this, sample populations, then their relations, okay. Then probability distribution of yi. So if you're selecting any unit from population, what will be their probability? So we have shown that the probability is same, is 1 upon capital N in the both the cases, which is 1 upon. So sometimes they will, in exam it is going to ask for 5 marks, show that under SRSW under SRSWR and WOR, the probability of drawing a unit from the population is 1 upon capital N. It's like theorem. It's like theorem. Okay, it's not like straightforward questions will be not given to you. You have to understand the questions, how the questions can be asked. Then you have to do this all derivations, second, first, second, both, because it is showing that under SRS, means under simple random sampling. See, if they have not mentioned WR or WOR, you have to do it both. Okay, you have to do it both. If they are mentioned, then you can go for according to the result. Then we have find the expected value of that drawing unit, variance of drawing unit. So basically, see, once we have that particular unit drawn, we are interested to obtain some characteristics, right? So mean, variance, correlation, covariance, they're all basically characteristics of that particular variable. Then under WR, we have shown that it is 0. So it automatically, because observations are independent to each other. So that is going to be 0. Sometimes under WOR, because WOR we have some derivations. So sometimes they will tell you find out what will be covariance between yi and yj. So it is going to be capital S square upon and show that this quantity sometime. So you should know from where actually we are asking the question. So that is a very important part. Okay. So instead of this, sometime they will ask you to show this covariance between this quantity is this. So see, there are so many questions are there. Only thing is that you have to understand the questions, how the questions can be asked in your examinations. Then we have unbiasedness, show that the sample mean is an unbiased estimator of population, right? So you can go by this one. Then you can find out variance, right? Under, so see, if they're asking for variance, if just they will ask you for the variance, nothing else, then you have to do it both. SRSWR, SRSWOR, both cases. But specific, if they are asking like under WOR or WR, then you have to do it that much only. Always understand those concepts. Okay. But if it is asked for 10 marks, I think that is sufficient. And then show that WOR is a more efficient than WR, because the variance is less in this quantity, right? Variance under WOR is less as compared to WR. That's why it is more efficient. Then we go for estimation of variance. Estimation of variance means, since we are dealing with the population, but the population sometimes unknown, so to replace their estimates. So what will be small s square, and based on small s square, we have to just check whether this small s square is equivalent to what quantity. So we have shown that it is equal to sigma square. So one can get directly estimates. Okay. So small s square is equal to sigma hat square. So sigma hat square can be replaced by small s square. Then in WOR also have to follow same procedure, and hence we get this result. So we can just go through this. Then we are interested in estimates of the variance of R. Estimates of the variance of R. Estimates means you are just making the cap. There are both notations are given. Whether you can use V hat of y bar, or you can use small y, small b, sorry, it is small b. And then based on that, you can just find out their expected value, and we have shown that it is equivalent to your variance of y bar. So sometimes they will ask you show that variance of uh, estimated of variance of y bar is unbiased estimator of variance of y bar under WR. So there are list of questions are there. Huge amount of questions are exist. The only thing is that you have to understand questions, and based on the questions, what will be the answer, we have to write it down. Then we're talking about the population total. So population total is similar to your mean. The only thing is that we are not talking about mean, we are interested on total. So total can be written as n into capital Y bar. So if I use estimate again, it's become small. Then you can find expected value, you can find variance, you can find hat. Okay, that's all is going to be same. And then we are moved on confidence limit. And we have seen two cases. If sigma square is known and sigma square is known and sigma square is unknown. Okay, so if I'm using t here, so if t is there, then sigma square is unknown. So make sure that you should know both one. So sigma is unknown, you can go for t. Sigma is known, you can go for z. So again, there are two cases based on the n is greater than 30. We know also you should know only one this first derivation. If you know this first derivation for confidence interval, it is very simple. You can do any derivations in the case of whether it is known or unknown. So just try for practice of first derivation, because rest will be you're just changing the variance. In WR you are changing just variance. Okay, so you get this expression. Once you get this expression, sigma square is unknown, then you replace by their estimates and you get this expression. Again WR, so I will not going to derive everything, so I have written directly. Now you can see here how this confidence interval. Now in examination, what happened? If the examination, they will ask you find out 95% confidence interval for some problem. So you are not going to write it down whole derivation. Okay. So in that derivation, what you have to do? It is your population mean minus z alpha by 2 into this is your standard deviation, which is sigma upon root n. So that's what I'm telling you. You always remember the mean and variance. This is the variance. Okay, so sigma upon root n is your variance. So simply you can just multiply with your standard normal value with the standard deviation. Similarly here also you multiply with standard normal value with the standard deviation. The standard deviation has become this. Okay. And if this S square is unknown, we can go for their estimates. So that was related to when sample size is large. But if it is small, then we know that that follows t distribution. So for this is the just expressions which I have shown you, but this is just for your knowledge. It is not required to write in an examination. Just know this result. This result is important. To get t variates, we need one standard normal variate and one chi-square with k degree of freedom. So if you just take the ratio of that, it follows with the k degree of freedom, and then you can write the result, and then this whole derivation is going to be same because this is standard normal variate, and you make little bit adjustment. Consider this s square and divide by sigma square both sides, and we know this follows chi-square with according to the result of t SNV upon chi-square with n minus 1 degree of freedom. So just write this result, and based on this you'll be get this final expression. Once you get this final expressions, as soon as you will find the final expressions, the whole derivation you can immediately write it down by, because this is your mean, this is your standard deviation. तो final expression directly क्या आ जाएगा आपको y bar plus minus t alpha by 2 comma n minus 1 s upon root n. Directly you can write. Means if it is in theory, then it is you need to derive this. But if it is practical, then you should know immediately how we can means which formula is going to be useful for. And similarly, you have to do it for exactly same fashion. We have to do it for WOR. And then we move to the attributes. So in attributes also, you should know capital P is A upon N, then capital Q. Then we have defined the indicator function yi, and then with the help of sample, we have small p sample proportion. Then you have to define the sample mean population, population mean square, sample mean square in terms of samples. So you can have capital PQ proportions, sample mean square in terms of proportions, and then you can go for their unbiasedness, then their variance. This is the same as we are doing in the case of WR and WR. Then again, you have to do it for WOR, their estimates, then population total estimates, and then again move to the confidence interval. See exactly the same procedure we did as we did in the previous cases, and then move to the estimation part. So again, estimation, the concept is same. You compare with D directly in exam directly. You compare with D T into standard deviation. Get simplified, get the value. Because remembering all the formulas is quite difficult. So that's why I'm just giving the trick. I'm just now giving the trick. So you can remember. So if you know some steps, you can easy to get the value of sample size. You can easy to get the value of confidence limit and so on. And then you can just go ahead because I think those concepts I have already told. So you need to understand only this first derivation here. You need to understand only this derivation. If you know this derivation properly written 1-2 times, then whole derivation may only the variance will going to be changed. Only the variance is going to be changed. And remember, in the case of WOR, your sample size is going to be same as in the case of WR. When you take capital N is going to be large. So if capital N is going to be large, then sample size in the case of WOR is going to be same as WR. Okay. So sometimes they will ask you this result also. Show that if capital N is large, then sample size in WOR and WR is same as WOR. So you should know this all, like very simple question. And then you can ask for the derivations like approximations. So I think this is the whole overview of basically unit 1. So let me know if you have any questions. Yes. I think the only thing is now you have to work on this SRS and you have to take down, write it down all theory part and all derivations. You take your own time, write it down on the notes. If possible, if you do it, same thing will be same time. Like whatever we have studied today, and if you do it same thing, then it is good. Otherwise, the more things will be like you'll forget later on. Okay. So I'm just sharing the feedback form. If you have any questions, you can fill this feedback form. And still we have 5 minutes, 5 to 7 minutes time. So if you have any questions, you can ask. यस किशन जायसवाल बोलिए. No questions. Everybody knows everything. Oh, very nice.
Sir, what to write in topic?
Topic confidence interval.